Okay, this week we have been working on our algorithms for multiplying and dividing fractions, and we added in some information with improper fractions and mixed numbers. I just want to go over that a little bit more because we kind of went over some of that stuff very quickly in order to get all the notes for you. So first we're just going to do a basic improper fraction into a mixed number real quick. Feel free to take the notes. Some of you already have this in your notes, so just pay attention so you can recall. So first thing you have to do is you have to tip the cow in order to make sure you're setting up your division house properly. Your numerator, which in this case is 24, should be in the house, and then we're going to put 7 on the outside of the house. Well, so you have to see how many times 7 goes into 24, and you should know that 7 times 3 gives us 21, which is close as we'll get to 24 without going over. And then 24 minus 21 is 3. And now we're left with, in a normal problem, in a normal division problem, you would say, oh, it's 3 and it has a remainder of 3. Well, in this case, all of these pieces have a job. So this top number becomes your whole number, and this bottom number becomes your numerator, and the number outside the house is your denominator. So 24/7 is equivalent to 3 wholes with 3/7 left over. You should recall that from the notes that we took on Monday. Let's move on to mixed numbers into an improper fraction. When I showed this to you, we had 2 different ways that we could do this. One was by setting up your groups of wholes, and then whatever you had left over, and then adding the fractions together, which is a lot more work. And then the other one was with the trick. I'm only going to show you using the trick because it's going to save you time, and because throughout this unit, if you're taking so much time just to change a mixed number into an improper fraction, you're going to really get slowed down. I'm not saying don't do it. I'm saying I'm just going to show you the trick this time. And our trick is you take your denominator and you multiply it by your whole number. So in this instance, I have 4 times 5, which I know is 20. And then I need to take that product and I need to add the numerator to it. So I'm going to add 3 to it. So 20 plus 3 equals 23. Therefore, 4 3/5 is equivalent to 23/5. The denominator will not change. Either from improper fraction to mixed number or mixed number to improper fraction, you're always going to have the same denominator. Okay, well, what happens when you see this in a multiplication or a division problem? Then there's a little bit more work that you have to do. And you need to remember that before you start doing any multiplication or dividing, that you will always change your mixed numbers into improper fractions. And this will always happen before you start multiplying or dividing. So these are notes that if you do not already have them, you should go ahead and take. So let's do some examples. So let's start with multiplying, because we already know that it's a little bit easier than dividing. Say you had 1 4/7 times 6/11. Well, first I need to do 7 times 1, because I need to change my mixed numbers into improper fractions before I multiply. I can't go 4 times 6, 7 times 11, and then carry over the 1, because I'm not going to get a correct answer. 7 times 1 is 7. 7 plus 4 is 11. So now the problem that I have is 11 sevenths times 6 elevenths. Now it's pretty easy for me to just multiply straight across. 6 times 11 is 66. And 7 times 11 is 77. It's not too bad. It's pretty simple. Now when I got to this point, I have 66 77ths, and you're going to say, oh, you can't simplify that. Well, I can simplify that. It's just a weird number to divide by. I can divide both of these numbers by 11, and I know that because both of them just have the number repeating. Also, I multiplied both of them by 11 in order to get to where I am now. And if I divide 66 by 11, I'm going to get 6. And if I divide 77 by 11, I'm going to get 7. So my final answer to this problem is 6 sevenths. If you are not simplifying your problems, you're not going to get a correct answer. And you're going to say, Miss Sargent, there's not a right answer here. But there is. You just have to finish the problem. You can also cross cancel and simplify. So 11 and 11 both are divisible by the same number. In this case, they're both divisible by 11. So 11 divided by 1. 11 divided by 11 is 1. So I have 1 there. 11 divided by 11 again is also 1. So if I do that, I can do 6 times 1, which is 6, or 7 times 1, which is 7. And I'll get the same answer without ever having to simplify here. However, it's up to you. Some of you, this just gets confusing. So if you want to do it, do it. If you don't, don't. Let's do an example with a division problem. What if I had 2 and 1/2, and I wanted to divide it by 3? Well, my first step would be change this into a mixed number. Into an improper fraction. It's already a mixed number. I do that by 2 times 2 is 4, and then I do 4 plus 1, which is 5. So I would have 5 over 2, and then I'm dividing that by 3. Before I get any farther, I need to put a 1 under the 3 so that I know that I'm not doing 5 divided by 3 and then 2 divided by 3. Now this is set up properly, and I can keep, change, flip, and solve this answer. So keep the first fraction the same, 5 seconds or 5 halves. Change division to multiplication, and then flip 3 over 1 to 1/3. Now I can just multiply straight across. 5 times 1 is 5. Whoops. And 2 times 3 is 6. Now I have 5 6 as an answer. This cannot be simplified, so my final answer to 2.5 divided by 3 would be 5 6. You may go back and watch this video. You may pause, fast forward, rewind, get anything that you don't understand or don't have or need to go back for. Or you may move on to your next activity. Up to you.